I'm going to start in just a second, but before I do that, I will mention these are all open source slides, as is all of what else we're going to talk about. There's a URL to download them. Please feel free to snap a picture of that, or this is a pretty packed agenda. This idea that if you have a database or a source of data or some existing system that you want to expose as FHIR interfaces, hopefully that thing is okay. HAPI is designed, it's a Mac, it'll be fine. I've dropped mine lots of times. HAPI is sort of designed around this idea that whatever your source of data is, you can write some sort of glue code that will go and fetch data out of that data source, convert it into FHIR, and then expose it out. I think I have a slide about this later, but just in case I don't, I'll talk about the core use case that we originally actually created HAPI FHIR for. I worked at the time at a place called University Health Network, which is a great big sort of teaching academic hospital up in Toronto, Canada, where I'm based. And we, as many hospitals do, had just this giant mass of legacy systems and sources of data around the institution that included things like data warehouses, and we had a whole bunch of lab systems because, of course, we called ourselves best of breed, which really just meant we had a giant mess of systems we were too scared to replace. We had scheduling systems, at least 3 of them, because who needs more than one, like who can live with just one scheduling system? I mean, this is a common pattern in hospitals, of course. One of the things we wanted to do was start to take advantage of this trend of everybody in the world having phones in their pocket by allowing apps to be stuck on top of all of this. And of course, the last thing we wanted to do was come up with a bunch of point-to-point connections between phone apps and every one of the 150 systems at the hospital. That was naturally not a problem we wanted to try and solve in that way. Coincidentally, right around the time we were thinking about this problem, don't go to sleep, what are you doing? Right around the time we were thinking about this problem, FHIR came along. Like, this was basically 2011. We were sort of really heavily thinking about it. Looked at FHIR and said, this is a brand new standard that came out. It looks really cool. We recognize it's probably going to change a whole lot because there isn't even a 1.0 version of it, but it's better than anything else we would have come up on our own, so let's run at it. And we basically set to work at building FHIR interfaces using the old DSTU1 version of FHIR against a whole bunch of clinical systems to try and stand up sort of a rational set of interfaces, a rational set of web services that sort of abstracted away the complexity of the many, many, many clinical systems we had in-house. The net result there, as we sort of developed it, we realized this is useful stuff. We should probably open source it, and that's kind of the real short history of where HAPI FHIR came from. The reason I'm saying all of this is that the whole goal in developing the framework we developed to sort of build that architecture up was that we wanted to let a bunch of developers write a little bit of glue code. It was JDBC code that talked to the scheduling system, maybe, in one case, a little bit of V2 adapter systems that went to the HL7 version 2 query interface that was exposed by one of our EHR systems, adapted that out. Like the backends varied widely. In one case, it was like CSV files that were dumps of an Access database that lived on a doctor's desk, and I'm sure you've all encountered that if you've done any work in the hospital setting. Whatever the data sources were, we would develop a little bit of glue code. We would sort of talk to the backend data source. We would convert to FHIR resources using the data models I talked about yesterday. And the HAPI framework takes care of the rest. It deals with, takes care of the rest. There's a pun that's not even about FHIR. The framework would take care of all of the parts of standing up an HTTP server, parsing and serializing, understanding FHIR's rules for how URLs are structured, all of that stuff. So it really let the people who understand the data deal with that bit. So all of this is a really long way of saying you write a couple of classes that are your business logic for how your servers work, and HAPI, the framework, takes care of all of the rest of it. And this is the world's simplest architecture diagram that shows that in action. Let's dive into that a little bit. Well, I guess before that, I will say, these are the things. So certainly as you stand up a FHIR server, the first thing I will say as you stand up a FHIR server is that you don't actually even need any framework. And I've seen lots of people build servers completely from the ground up without using HAPI, without using the Vonk facade, without using any of the great frameworks that are out there to do this stuff. And it's perfectly reasonable to do that. FHIR is so simple that really you don't actually need a framework to do it. There are a lot of benefits to using a framework like any of the frameworks that are out there for doing this. However, and mostly those are around the various little sort of intricacies of how FHIR works. So HAPI does take care of the URL patterns that FHIR supports, FHIR's little escape rules for how search parameters get escaped when you've got more than one. There's all sorts of little sort of nitty-gritty details that exist within the standard, and HAPI takes care of all of that, as well as all just the plumbing of parsing and serializing and all of that stuff. The way this stuff works, and it's really simple actually, is you are responsible, like you the developer who are building a server with HAPI are responsible for really building actually just two things. The most important bit, and that's this thing on the right, is you build one or more of these things that HAPI calls resource providers. So a resource provider is just a class, it's just a POJO class that you create that implements a bunch of methods to do the FHIR operations you want to support. So if you are standing up a FHIR server and your FHIR server is going to serve up, for example, patient resources, observation resources, and encounter resources, and that's a pretty common setup, I think, for hospital sort of back-end facades. What you're going to do actually is you're going to write three classes: a patient resource provider, an observation resource provider, and an encounter resource provider. And each of those is going to have the business logic for talking to your database or your source of whatever your source of data is, and loading the data out, creating HAPI model objects, and then returning them to the framework so that the framework can do the rest of it. I will show you an example in just a moment of how those resource providers work, but I'll start by saying you create a resource provider. Finally, you'll create this one other class called the server class, and as I show here, your server class extends this thing called RESTful Server. RESTful Server is an implementation of Java's servlet interface, so this is just very straightforward servlet technology in Java. You create a server class. In this case, I'm just calling it foo server. And your server class does almost nothing, actually. All it does is register the resource providers you created. So it's really not a whole lot of code to get one of these things up and running. So you're ready to go. You've created the 4 classes you need for your server. The next thing you do, and this is, again, very textbook development in Java servers. I'm sure many of you have done this 1,000 times. You bundle up your classes into what Java calls a WAR file, a web application, or what is it, a web archive file, WAR. Any of the standard build tools out there, Maven will build these things just by changing what do they call it? The packaging type, I think that's the term they use. Gradle will do it. There's a basic Gradle plugin for it. Ant will do it. Any of the build tools that are out there will create one of these web archive files without any fuss at all. You bundle up the classes you've created, and ultimately you deploy it to one of the many servlet containers that exist out in the world. Tomcat is the most common of all of those. I mean, if you look up examples of how do I deploy servlets on the internet, it's almost always Tomcat they use as the example, and it's a perfectly good server. Jetty is another popular one. Jetty is personally my favorite. I really like it. Wildfly, the JBoss server, is another really popular one. And if you really hate yourself, you can use IBM's product as well, which I'm sure a bunch of you have been through that pain as well. So I hope nobody here is from IBM and worked on that stack. I personally have lost many hours of sleep and been woken up in the middle of the night dozens and dozens of times because of problems with the WebSphere stack. So what do the resource provider classes look like? Resource provider classes, and these again are the classes that implement your business logic, are very simple things, actually. They implement an interface called iResourceProvider. That's really the only rule we have. And there's one method on that interface, and that's the method I'm showing here, which is getResourceType. So all your resource provider actually has to do is tell the rest of the framework what type of resource it supports. Of course, it's not very useful if that's all it does, but that's the only thing it technically has to do. The rest of what you're going to throw into that server, into that resource provider class is logic for individual operations. So what do those look like? I'm not going to go through all of them just because there are tons, and we would be here the rest of the day, and I'm sure I'm already late because I was late. But I will show you a few examples, and this is the general pattern, is you're implementing a method for every one of the FHIR operations you want to support. So if you want your server to support a FHIR read operation, it's really simple, actually. You create a method, give it whatever name you want. All that it really matters is it's got this annotation at read, which is a HAPI FHIR annotation that says this is a read method. And that method should have at least one parameter that is annotated with @ID param. And that tells the framework that this parameter should be the ID of the resource that the user is trying to read back. And of course, in my example, I'm returning null, which is not a real example. In the real example, I would take that ID, understand that I should go to some database or some file or something like that, read the data back, create a patient resource, and return it from the framework. Everything else we do across various methods will follow those same patterns. So @create is for a FHIR create operation, @search is for a FHIR search operation, and the list goes on and on. If you're trying to do a delete, there's an @delete. If you're trying to support FHIR transactions, there's an @transaction, and it just goes indefinitely from there. I will drop out of here for just a moment to take you to the HAPI FHIR website. And hopefully I will spell that right, hapifhir.io. Our website is hapifhir.io. I know you can't read that. I will make it better, I swear. The thing I want to show you just really quickly is I've gone to hapifhir.io. I'm clicking on the documentation link. I'm going down to RESTful Server, and the second link there, I mean, the first one's also good, but this RESTful Operations link, if you want to know how to do anything as far as these resource providers go, they are all documented in fairly exhaustive detail in here, and that includes all kinds of exotic features of FHIR. So if I want to understand how to do a conditional create, which I won't bore you to death with how conditional creates work, even though they are really super cool things. If you want to know how a conditional create works, of course, there's a great big example that shows you the annotated parameters you need for a conditional create and some discussion around what they do and what the URLs look like and all of that stuff. So whatever the thing you're trying to accomplish on your server is, there's probably examples. And again, it's just documentation, RESTful server, RESTful operations. That takes you to that page with all of the information. Whoops, that's not the slides I wanted to. So let's go back. And that's the link to that. So this is a direct link, but of course, the easiest thing is just go to hapifhir.io, and it's 2 clicks to get into the documentation about how that works. The final thing you need to do is create one of these REST servers, the RESTful server. This is a complete example of that class, and as I said, it really doesn't do a whole lot. There's kind of 2 things you have to do. Well, one thing, I guess. You have to override this initialize method in your RESTful server class. You have to give it a FHIR context. As I was saying yesterday, everything in HAPI FHIR requires a context. So we create one here, and then you register one or more of these resource providers. Or you can even skip that, and then you've got a server that will do nothing except for create a capability statement. So that's really all you need to do to create one of these things. It is a very simple sort of process, actually. Just to show you sort of a complete example of this, and I think for time constraints, I'm not actually going to run this, although I do often do that within the demo. So I'm not actually going to show you the server in action. But the one thing I will do, just because I actually don't need to show it to you, it's easy enough for you to do this yourself. I am going to go to the FHIR starters GitHub repo. If you would, let me make that big so you can read it. This repository, I spoke about it yesterday, and I will mention it again today because it's great. This is the FHIR starters repo. It's on Firely's GitHub account. This is a clearinghouse for starter projects in all kinds of languages. There are examples, there's lots of examples for HAPI, including the one I'm about to talk about, but a bunch of others as well. There are .NET samples, there are browser samples, there's a bunch of iOS samples in here. So if you want to play with any of the languages that are in here, we're trying really hard to encourage the other languages to get their stuff in this repo as well, because this is a good clearinghouse. The thing I want to do is go into the Java directory, because who wants anything but Java, right? And then I'm going to go to this REST server skeleton. So this project here, the REST server skeleton project, this is a basic Hello World project for the HAPI FHIR server. It's complete, it works, you can check it out, you can run it. All of the instructions are in those slides as well for that. I will put up the link at the end as well for those slides, so you'll know how that all works. So this project, for sure, it's good. And maybe if I have time, I'll actually I'll run it at the end as well. But certainly, yeah, I guess the other thing I should say is if anyone has any trouble with this, I will be floating around here, probably upstairs the rest of the day. So by all means, come and grab me. I'd love to walk you through getting the server up and running on your computer if you're having any issues with that. The next thing I will talk about is interceptors. Interceptors are sort of the next major thing if you're trying to build up a server. Of course, HAPI, the server by itself, gives you a fully working REST server. The first question I hope you're all asking yourself is, what about security? Because we're all, we're all building healthcare applications. We all understand that most of the time you got to have security on anything to do with healthcare. The server framework is not just for, or the interceptor framework is not just for security, but that's one of the primary use cases of it. Interceptors in HAPI are essentially a method for wrapping logic around all of the processing in your server. And they're super powerful things, actually. The way they work is there's an interface, this interface called iServerInterceptor. You implement that interface, and then you override any of the methods that you want that are sort of allowed to intercept various parts of the processing chain. Interceptors can do all kinds of things. They are allowed to look at the requests as they come in. They're allowed to decide to handle the requests themselves or to block the requests if they want. They're allowed to change the parsed content, so they have the ability to go in and modify content that came from the client before the server sees it. They're allowed to block parts of the content before the server sees it, if that's what you want to do. They're allowed to change which parts of the framework will handle a given request. And then they have a bunch of power on the responses as well, essentially that same set of power. So they can block responses, they can modify responses, they can examine responses. They've got all kinds of power for that. There's a whole bunch of methods in there. I'm sort of listing out, and this diagram sort of shows you in not enough detail probably to fully appreciate all of it, but there's a whole bunch of parts along the request processing pipeline inside HAPI where you can hook in and add your own logic. There is a page on the documentation that sort of goes through what each of these methods do, and of course there's Java docs in there that give you a bit of hint about that as well. So this is a framework that allows you to embed whatever logic you need into the server, including all kinds of things. Naturally, the HAPI framework comes with a bunch of interceptors that are packaged along with it. You're allowed to create your own, but there's a bunch of good ones that come with the framework. Logging interceptor is probably the most useful of all of them. Logging interceptor, as you can probably guess by its name, logs every request as it comes in. It is a super customizable interceptor. The Java docs, which are right here, maybe I will click on it. So the Java docs, they have this, it's got this really nice sort of variable templatable thing where you can create an access log of whatever format you want. You've got all the power in the world to log request bodies or request headers or response bodies, FHIR operation types, source IP addresses, encoding, FHIR details. Whatever the thing is, there's all kinds of substitutable variables in there. So you can create really nice access logs that sort of fit whatever pattern you want to fit. That thing is pretty cool. If you're trying to support cores, there's an interceptor for that. If you're trying to validate payloads, so you want to validate either your requests or maybe your responses, there's a a request and a response validating interceptor, and that thing is configurable so that it can block invalid responses or invalid requests. It can flag them, it can tag them, it can log them. So depending on what you want to do with validation, you can customize it to do the thing you want to do. Response highlighter interceptor is super useful. If you've ever used any of our public HAPI test servers, you'll notice that they have this really nice blue and purple theme. I don't know where we came up with those colors, but they pretty print everything and they use a really nice sort of pleasant on the eyes format for the output. That is actually a product of the response highlighter interceptor. So that is the module which sort of gives you this nice colorful pretty print when it detects that it's a browser making a request. And finally, we've got this thing called Authorization interceptor, which is so cool that it deserves its own discussion, which I will come back to in a second, I guess. The way that you use interceptors is Super simple, actually. This, again, is my RESTful server class. All I actually have to do, and I show an example of it at the bottom, is call this register interceptor method and then register whatever interceptor I want to. If you look at any of our public examples, there's all kinds of HAPI/FHIR examples on the internet out there. Every last one of them, if it does nothing else, is always going to use that response highlighter interceptor just because it looks super nice. Almost to the point where I think it should be a default, but it isn't. So you got to do that one step if nothing else. So we're back. Authorization interceptor. Authorization interceptor is certainly the most powerful of the built-in interceptors. It is the framework that you would use to build up authorization capabilities on top of your server. It is not a complete implementation of authorization. We get the question all the time, do you have an OAuth 2 module? And the answer to that is, at least for now, no, we don't have an OAuth 2 module. We've thought about it, but what we do have is something that allows you to create an OAuth 2 module. And the idea here is that every organization that you're ever going to go to is going to have slightly different rules for what authorization should mean, how are users authenticated, what should those users be allowed to do. The rules are always different. The framework allows you to implement those rules in whatever form they take. The way the authorization interceptor works is this sort of declarative mode where you examine the response that's coming in, and that means you looking at credentials in code you write, you going to your LDAP or your Active Directory or your data store or your user database or calling your authentication service, like whatever the authentication architecture is that you're supporting, you go and talk to that system. You figure out what the user is allowed to do, and then declaratively you tell the authorization interceptor, these are the things this user is allowed to do. So you tell it that this user is a patient with ID 123, so that user should only be allowed to look at data that belongs to patient 123. And maybe they're allowed write access to certain types of data, but not other types of data. Maybe they're allowed to pull down capability statements because they're anonymous, but nothing else. Whatever the thing is that that user is allowed to do, you write a bit of code to declare what they can do. The interceptor does the part that's hard in all of that. And this is why I say the OAuth 2 thing. We don't do the last bit, but we do the hard part. The authorization interceptor actually enforces all of that. So it will block the user if they're trying to do a read on patient 123's data, and they're only actually supposed to see patient 456's data. Whatever the rule is, the authorization server interceptor will actually enforce that. So very useful tool to have in your toolbox. And essentially, if you're building a real production system with HAPI/FHIR, you probably will end up running into authorization interceptor. Certainly, you don't need it. There's other ways of building secure systems, but it's useful if you're doing that type of thing. This is an example of what it looks like. Hopefully, you guys can read that from the back. Authorization interceptor, there's a single method in there that you override, this thing called build rule list. It gets this thing called the request details, which has all the details about the request coming in. The usual way you would use this thing is you would pull out your authorization header from it. You would get the credentials from that, go talk to your user database, figure out who the user is, what are they allowed to do, all that stuff. And then you use this thing called the rule builder. And the rule builder is where you declare what the user is allowed to do. So in my example, I am calling the builder to say this user is allowed to call the metadata object. They're allowed to read every single resource on the server because that's what I want them to do. And just for the sake of example, I'm going to say they can read everything, but they're only allowed to write observations for this one patient. I can't think of a real reason you'd want that set of rules specifically, but that is, it's a good sort of example. And for this, we're using what FHIR calls compartment-based access. The FHIR compartment, this basically means any observation that has a subject or a patient relating to that specific patient resource. So basically observations about that patient. There's lots of ways of doing this. And the authorization interceptor and its rule builder is an extensive framework. There's a lot in there. The final thing I'm going to do with my remaining 5 minutes is talk about the JPA framework, which is the last little bit. Everything I've showed you so far involves you having your own sort of sources of data, your own database that stores your resources. If you're starting fresh, if you want to stand up a FHIR server and you don't have an existing database, the easiest way to go about that then is to use our JPA server framework on top of that. The JPA framework is a complete sort of implementation of the underlying database schema, the underlying storage modules, all of that. In other words, JPA server is a complete FHIR server out of the box. It uses all of the same stuff. It's built on top of the rest of the HAPI/FHIR framework. So you still have the ability to plug in the authorization interceptor, the other interceptors. You still can deploy it to any of the application servers I talked about. But it comes with a complete implementation of the resource providers for all of the operations, almost the entire FHIR spec, actually. It includes the basic stuff like creates and reads and updates. It includes all kinds of fancy stuff like conditional updates and version-aware updates and transactions and patches, all kinds of stuff like that. Supports terminology, supports subscription, has a million things you can configure based on your requirements. I find it kind of delightful to play with anyway. It's got lots of stuff in it. The way it's built, it uses a library called Hibernate, which every Java developer in the world either loves or hates. I will certainly say that. I suspect if I pulled the rule, half of you hate Hibernate. Half of you probably used it a million times and loved it. That's fair. The nice thing about Hibernate is it's an ORM, and like any other ORM framework, it abstracts the database out a little bit. The nice thing about that is that this framework will live happily on top of Postgres, on top of Oracle, on top of SQL Server. There are people using it against Derby for testing, although I wouldn't recommend that in production. There's people using it against Firebird, so all kinds of databases it works against and works against quite well. We also take advantage of Apache Lucene, which is a full-text indexing engine for a bunch of things, including terminology lookups and full-text searching across resources. So there's a whole bunch of power that exists within that framework. Yeah, there we go. So I guess, final thing about that, there's not a whole lot more to say about the JPA framework. To use it, there's not actually much you need to do, just because it is a complete sort of FHIR solution, including all of the components you need. The easiest way to start playing with the HAPI FHIR server is to just check out the example. Again, this lives on the FHIR starters link. This one doesn't say Firely, it says Furore, which is the old name for Firely. But this link goes to the same place. If you go and look at the HAPI FHIR JPA server example project, this is a complete Maven-based project that you can use to stand up a JPA server. The last thing I'll say about the JPA server, if you want to take it for a spin and you don't want to even create an application server, we do have a command line version of it available. That's this tool called the HAPI FHIR CLI, the command line interface version of HAPI FHIR. If you go to our website, you will see links to download the CLI tool. And starting this is super simple. You download it. There's a command which is not in a nice color to read at the back. It says HAPI FHIR CLI space run-server, and then finally -f dstu3, which tells us which version of FHIR we want to support. That thing will start, and from that moment on, I've got a private FHIR server running on my computer that I can play with. This thing works in all kinds of contexts. There are people running the CLI on Raspberry Pis and on giant servers and everything in between. It's a fun little bit of tooling. I've seen some neat demos, actually, of people doing Raspberry Pi-based FHIR servers for kind of interesting things. So that's a use case I like quite a bit, actually. Yeah, that's that. There is an exercise here. If you want to go through and create your own server, I would certainly recommend doing that, running through the exercises. And I think that's that. We went through this stuff yesterday. Cool. So that's actually it. I'm going to back up all the way to the link with the slides URL in case anyone wants them. If you want to go through this stuff, again, that's the URL. There are links to all the tutorials, links to all the demos, and come and grab me if you want. I'm around, and I love talking about HAPI. Thank you.